When it gets to the ribosome has two subunits too. It's the large subunit and the small subunit. And the large subunit has 3 locations where tRNAs can fit in. And these are called the E, P, and A sites. Now, where does the mRNA molecule go? The mRNA molecule is going to be found bound to the small subunit The nucleotides are read in combinations of 3 bases. So A, U, G. This is RNA, so obviously there would be no T's. You would only have U's. U, G, C, 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 A, U, G, U, C, G, A, C, G, on and on and on, right? These are what we call codons. Now, that's all well and good. We have the codons. We have the ribosome, which is kind of our workbench for doing the work of translation, but we still need a translator to come in here. We need a way of reading this information and translating it over to polypeptide language. That'll be good. And the thing that does that are called tRNAs. tRNAs have what we call anticodons. Which just have the opposite set of bases, the complementary set of bases to these codons. So this is how they read them. Why are they called anticodons? Well, you see how this says AUG right here? That's the first codon. The tRNA that binds to that would have an anticodon which reads UAC. So they're anticodons because they're compatible. They are mirror images of the codons here. So codons just fit to anticodons. That's why they're called anticodons. So we'll remove that one for right now. That makes more sense. Good, good, good. So on one side of the tRNAs, you have the anticodon, which reads the message. On the other side, you have an amino acid. And only the tRNA with the correct anticodon will have a certain amino acid on it, right? So it's not random which amino acid and which tRNA come together. They are specific, right? Methionine is only going to be attached to a tRNA with UAC as its anticodon, and other amino acids also have specific anticodons that they will be attached to. So what happens, let's say that this anticodon says U. Several anticodons might try to come in and match up. I think I made this too big. Several anticodons might try to come in and match up, but only the one with the correct anticodon is actually going to fit. So AAA matches to UUU. So then we know that this anticodon is the next one in the chain. And then after that, the whole message is going to move down 3 letters. New tRNAs enter through the A site. Codon recognition occurs there. And then the whole thing moves down 3 letters, which is called translocation. Now, when we have 2 tRNAs, one in the A site and one in the P site, so let's say I have, let me get rid of this arrow. Let me say I have a new tRNA here, and this one says G, 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 so that anticodon matches with that codon, and this will have some other amino acid attached to it. What happens is that we'll get a peptide bond between the amino acids at the A and the P site. So it's called the P site because peptide bond formation occurs there. Now, when we translocate again, the one in the P site is going to let go of its amino acid, and it's going to end up here in the E site, which is the exit site. So this one would say G, C, G. It's going to leave empty. It's lost its amino acid. And as this chain keeps going through, as we keep moving down 3 letters at a time, getting new codons and new tRNAs entering, we are going to get more and more amino acids being added to this chain. So over time, 3 letters at a time, the ribosome is going to synthesize a polypeptide through this process. And this is called translation.